Assalamu alaikum warahmatullahi wabarakatuh. Just decided to do this live today to discuss the questions that I made for GCSE Quadratic Sequence. Now, if you would like to, there are two parts to this. If you would like to understand the mechanisms behind Quadratic Sequence, I will have to make another video for that. Today's live is solely for the purpose of solving the questions that I have put in my Quadratic Sequence booklet. It's a 3-page booklet, and if anyone wants it, please refer to the description in the videos later on, where I will post a link to the file. So let's start. The booklet has got 6 questions. The very first one is the simplest type of quadratic equation, where a set of values will be given, as a few terms of the sequence will be given, and we are supposed to find the nth term of the sequence based on that. So if you look at these values here, so we are given a set of values. This is the first term of the sequence, second term, third term, and fourth term, 7, 11, 17, and 25, and we are supposed to find the nth term of the sequence. So again, the mechanisms behind this will be uploaded in a separate video. All I'm doing is doing a few questions from the booklet, so that people who have already read through the document and is finding it hard to solve some of the questions can refer to this video and solve those questions, or get help to solve those questions. So as you can remember from Quadratic Sequence, what we do first is we find out the first differences. So the first difference between 7 and 11 is plus 4, between 11 and 17 is plus 6, and between 17 and 25 is plus 8. And because of this is Quadratic Sequence, we know that the second difference will be constant, plus 2 and plus 2. Now what we are looking for is a n squared plus b n plus c. So basically we are looking for a, b, and c. The a, finding out the a is really easy. The moment you find out the second difference, this is called the second difference. And a is second difference divided by 2. Now why is that? Like I said, it will be in the other video where I will explain all the mechanisms behind this. So it would be 2 divided by 2, which is 1. Now the rest actually follows only the formulas. To find out b, so that is a, to find out b we use another formula, which is 3a plus b is equal to difference between first and second term. So in this case 3a, so already we know the value of a, which is 1. 3 times 1 plus b, which we don't know, is equal to the difference between the first and the second term, which is 4. So we find out that b is equal to 4 minus 3, which is equal to 1. I'll change the color of these pens so that you understand how I did c, so that it's all in one board. So c is again very simple. The formula is a plus b plus c is equal to the first term. That's the formula for finding out c once you have found out a and b. So a we already know is 1, b we also found to be 1, plus c is equal to first term. So it becomes simple. C is equal to 7 minus 2, which is 5. So basically what we found is, using these 3 different pieces of information, we found out that a is 1, so I can write as 1n squared, or just n squared, plus 1n plus c, which is 5, and that is our nth term of this sequence. Now let us check if it works for all the other values. This is the 4th term of the sequence. So if I put 4 in here, I should get 25. So 4 squared plus 4 plus 5 gives me 16 plus 9, which is 25. So we have found out the correct answer, which is n squared plus n plus 5. So all of the questions in number 1, again I'm referring to the booklet that I have made. So if you want that booklet, please leave a number, leave a text, or so because it's from UK. If you are on WhatsApp, if you could text me on this number to and mention which booklet, because in my YouTube channel you will find many different videos from now on many different topics. If you want those booklets, it's here, or later on when I edit the video I will put a link to my test account or my Dropbox account where you can download the file from. But for the time being, if you want it now, this is the WhatsApp number that you should text it to get the booklet. So it's a UK number 07904 376256. Okay. Going back to the second question, the question says a sequence has a, so let me just copy it here if I can. Okay, so this is the question. Okay, so let me take it to one corner to get some more space for our working out. Okay, so the question is a sequence has an nth term of n squared minus 6n plus 7. Work out which term in the sequence has a value of 23. So this is now taking us into a different direction, a different type of question. They're saying n squared minus 6n plus 7 is equal to 23. You're supposed to find out what n value gives 23. Now you can do trial and error. You can start by putting 1 and 2 and 3 and 4, but there is no guarantee where you would get the correct answer. It might be the 20th term, it might be the 15th term, and a question like this will have in GCSE 3 or 4 marks. You don't want to lose that much time to find out the answer, so you need a proper method. So what we are doing here is solving it by solving quadratic equations. So what we will do is we will make it into a quadratic equation by bringing the 23 to the left hand side and equating it to equal to 0, because we need this format if we want to solve the quadratic equation. So n squared minus 6n minus 16 equal to 0. Sorry, 0. Now all we have to do is factorize it. So we are looking for two numbers that multiply to give me 16 and minus 16 and add up to minus 6. So we are looking at minus 8 and plus 2. Now the two values would be n equal to 8 and n equal to minus 2, but as we can see, we know from the knowledge of quadratic sequence, a term, the nth term cannot be negative because it's an integer, a positive integer. So we are looking at n equal to 8. Now the answer is obviously work out which term in the sequence. It's the 8th term. Now imagine you want to find out using trial and error. You will have to put excuse me 7 different values in that formula until you go to the correct answer, which is the 8th term. So it's always better to approach it this way. The question says a sequence has an nth term this, work out which term in the sequence has a value of 23. Okay, let's go to the second question. Now this question here is joining quadratic sequence with proofs, algebraic proofs. Okay, so we are supposed to prove that every term in the sequence n squared minus 4n plus 21 is positive. So again, it's more of an algebraic proof question than a quadratic sequence question, because we are not going to use any of those skills here. So we have to prove that n squared minus 4n plus 21 is positive. Okay, now although we are doing quadratic sequence, let me give you some tips regarding algebraic proofs. The moment you hear the word always positive, the moment you hear that something is always positive, it means you are gonna put it as a whole square. The expression that they've given is can be put into a whole square, and we know that squares can't be negative, because when you multiply a number by itself, even if it's a negative number, it becomes positive. So we are dealing with n squared minus 4n plus 21. So what we are going to do is we are going to try to first of all try to see if we can put the whole thing as a completed square. Otherwise, just make completed square using the first two terms and see where it takes us. So in this case, completing square would be n minus 4 over 2. Again, those who have done completing square should understand it. If not, I will do a separate video on solving completing square. Or actually, I have got a quadratics booklet that I have prepared. If any of you want it, please go back to the previous I think about 2 minutes back. I've provided a number that you can text me in, where I would give you the booklets. So completing square is n minus that squared minus the same thing squared, and there's a plus 21 at the end anyway. So that becomes n minus 2 squared minus 4 plus 21. Again, please note that this minus is outside the bracket. So if you are thinking, oh, just now we learned squares cannot be negative, why is it still negative 4? It's because the minus is not getting squared. The 2 only is getting squared. The minus is outside the bracket, so minus is not getting squared. So what we are left with is n minus 2 squared plus 17. What it shows us that a square is always positive, and when it is getting added with a 17, it will be positive. Okay, so if you want to make an end statement, is that n minus 2 squared is always positive, and adding 17 to it is not going to make it negative. I hope this is clear to you, for because I have chosen that this video has been made specifically for kids. It will not allow you to comment or have a chat with me. So let's go back to the next question. Question number 4 says the nth term of a sequence is n squared plus 3n. Two consecutive terms of the sequence have a difference of 38. Work out the two terms. Again, it's more of a to be honest with you, algebraic question, algebraic proof question. Okay, so let's solve that now. So we are dealing with n squared. So we have the sequence n squared plus 3n. They are saying in the question that two consecutive terms in the sequence have a difference of 38. So we are talking about nth term and n plus 1th term. Why? Because consecutive. If I'm dealing with a term, the next one would be n plus 1. The next one would be n plus 2. So what we are doing is we are trying to find out which two terms will do that, this term and this term, the difference between them is 38. Okay, so to do that I have to put this into the equation and that into the equation or into the expression and find out the difference and equate it to 38 to solve it. So if I put n plus 1 in that equation, okay, it becomes, so let me just for your understanding, let's write it like that. So this will be my nth term and this bracket will be my n plus 1th term. So when I put n plus 1, I get n plus 1 squared plus 3 times n plus 1. In here it stays the same because I'm just replacing the n's with n, so it does not make any difference. So when I expand this bracket, I get 2n squared plus 2n plus 1 plus 3n plus 3, and when I expand this bracket I get n squared minus 3n. Again, remember that because there is a minus in front of the whole thing, everything will change sign. And because I am there is a 38 in there, which I will write. So as you can see, there is an n squared here and a minus n squared here, which cancels each other. And if I simplify all the n's, I get 2n, because the 3n and the 3n will also cancel each other. So 2n plus 4 equal to 38, 2n equal to 34, n equal to 34 divided by 2, which is 17. So what we are looking at is that we are looking at the 17th term and the 18th term of the sequence. Okay, if you want to check it, let me write it with red pen. So we want to find the difference between these two. So we are saying 18 squared plus 3 times 18, and we are saying 17 squared plus 3 times 17. So 18 squared, if I am not wrong, let's find out. 18 times 18 is 324. 324, add 54, take away 17 squared again. So 17 squared gives me 289. 289, take away 51. So 324 add 54 gives me 378, and 289 add 51 gives me 289, 290, 340, and 378 take away 340 will be 38. I hope this has, this makes sense to you, because this is pretty straightforward. All we have to know is some knowledge of algebraic proof, and the rest follows. Because to be honest, we didn't do anything to do with quadratic sequence here. They just mentioned in quadratic sequence here because it's a quadratic sequence, but we didn't use any of the knowledges that are required in quadratic sequence. The next question is the 5th question, and I want your attention on this question because it's quite interesting. Remember, even if you can't leave any comments or have a chat with me right now, you can always leave a comment in the section below, and I will try to answer your question there. So we are dealing with this question now. Very interesting question. So let me just. So we are dealing with this question, which says the nth term of sequence is 3n squared plus bn plus c. So let me just write it here if it is too small for you. 3n squared plus bn plus c. the first four terms of the sequence are minus 10, x, 0, and 14. Find the values of x, b, and c. Because we already know a, they are asking me to find out b, c, and this unknown here. Okay, so the very first thing we will do is that we will treat it as any other quadratic sequence, and we will say that the difference between these two is x minus 10, difference between these two is 0 minus x, difference between these two is 14. So let me just simplify that for our convenience. X plus 10, this is minus x, and this is 14. And the second differences are obviously minus x minus 10, and this one would be 14 minus x. So basically this has become minus 2x minus 10, and this has become 14 plus x. Now if you remember right in the beginning, in question number 1a, I said half of the second difference is a. So this is our second difference, minus 2x minus 10, and if I half it, I should get a is given, which is 3. So if I rearrange it, minus 2x minus 10 equal to 6, minus 2x is equal to 16, x equal to minus 8. So basically the value of x is already found, x is minus 8. So if I write minus 8 here and actually rewrite the entire thing here, it becomes minus 10, minus 8, 0, 14. Now why am I doing that? It's because now that I know all the numbers, it will make it easy for me. The difference between these two is, so x plus 10, which is minus 8 plus 10, would be plus 2. Now if you remember, again, let me just write it with a different color. To find out b, we use a formula called 3a plus b equal to the difference between the first and second term, which is our 2. And a is already known, which is 3. So 3 times 3 plus b equal to 2. And finally b is equal to 2 minus 9, which is minus 7. So we found out our value of b to be minus 7. And for c, what we do is we do a plus b plus c equal, okay, actually let me change the color of the pen. So a plus b plus c is equal to the first term, which is in this case minus 10. So a is 3, sorry, a is 3, b is minus 7, and we are trying to find out c. So we have minus 4 plus c equal to minus 10. So c would be minus 10 plus 4, which is minus 6. So basically the equation that we're looking at is 3n squared minus 7n minus 6. Let's check if it works for the third term. The third term is 0. So 3 times 3 squared minus 7 times 3 minus 6, which gives me 27 minus 21 minus 6, which is 0. So our values are correct. What did we find? We found x equal to minus 8 and b equal to minus 7 and c is equal to minus 6. I hope this is clear to you. At this point I will just guide you to the Facebook page for my online school, which is so it is, if you go to facebook.com/tutor Sami, that's my Facebook link, Tutor Sami. That's the Facebook page. If you subscribe to it, you will get regular updates from me. We now go to the very last section of my booklet, question number 6. Again, I didn't this is not a I would say it is not a very comprehensive, not comprehensive, not a very long list of questions for you to practice. You can always find questions like this in a Google search, or if you want me, I can make one for you. But what I have tried to do here is give a mix of everything that you might have to face in GCSE exams. So this last question is my favorite. Okay, so if you look at this question now, find the nth term of the quadratic sequence with the following terms: 10, 33, x, and 91. So we will take the same approach as we have done before, same as with any quadratic sequence. The first difference here, so not the first difference, the difference between 33 and 10 is 23. This is x minus 33, and this is 91 minus x. And then the second difference is x minus 33 minus 23, which gives us x minus 56, and these two give me 91 minus x plus 33. Again, I have already discussed, I'm minusing this difference from this difference. That's why x has become negative and minus 33 has become positive. So if I simplify it, I get 124 minus 2x. Now remember, this is a second difference and this is also a second difference. So they must be equal, because we know in a quadratic sequence the second differences stay the same. It is the same. So what we are doing is we are equating these two. X minus 56 equal to 124 minus 2x. If we rearrange it, I get 3x equal to 180, I believe. So x would be 60. So we now found out the value of x, which is 60. So let us make a new line here with the new values. So we have found, so the first term is 10, second term is 33, third term is 60, and the fourth term is 91. That will make our life easier to find out the A, B, and C's. The difference between these two is 23. Difference between these two is 27, and difference between these two is 31. And the second difference would be, we could have found it in terms of x, but let's just do it the normal way. 4, 4. So A is half of that, we know, so 2. And 3a plus b is the difference between the first term and second term, which is 23. So we found out b to be 23 minus 6, which is 17. And finally, we know that a plus b plus c is equal to the first term. A is 2, b is 17, and c will be equal to 10. So c is 10 take away 19, which is minus 9. So if I want to write the answer down now, it would be an squared, so 2n squared plus bn, which is minus 17, sorry, no, plus 17 minus 9, which is the c. So let's just check it for any other value. So let's check it for first term. First term means I will put 1 in here, so it will become 2 times 1 plus 17 minus 9, which gives me 19 minus 9, that is 10. So we have solved that question as well. I hope this video has been beneficial for you. I would encourage you to comment in the section, comment sections of YouTube, or even subscribe to my Facebook page to get free resources that I promise to keep free for the rest of my life. Teaching is my passion. I would never charge money for a YouTube video or any material that I produce. So subscribe to my YouTube channel if you want to get more videos, or get notifications for more videos like this. Stay safe in this time of coronavirus. I will see you again when I do my next live video. Thank you very much.